So we'll carry on where we left off in the previous video. So you've drawn the following situation on your graph paper, and we're going to draw the objects on, and then we're going to try all of these different diagrams and see what sort of images we get, whether they're upright or inverted, real or virtual, magnified or diminished, and see where the image position is. So here's the first one, an object outside of 2f. So we've got our sort of basic outline for the diagram, and we put the object in outside of 2f. Here it is. We're going to draw in the ray parallel to the axis from the top of the object. At the midline of the lens, it changes direction and goes through F on the axis. Make sure we put some arrows in to show the direction of the ray. Then we draw in the ray from the top of the object through the center of the lens, and we know it doesn't change direction and it crosses over. And so this is where the two rays are going to cross over. We can then draw the object in like this, and we can then start talking about what type of image we have. So in this case, we've got a real image because I could put a screen just here and it would the image would be on the screen. It's inverted because it's upside down, and it's diminished because it's smaller. And this is for an object that's outside of 2f, we get an image position between f and 2f. If we put the object at 2f now here, so we've moved it a bit closer, and we draw the ray that is parallel to the axis, and it changes direction at the midline and passes through F. And we draw the ray from the top of the object that passes through the center of the lens and doesn't change direction. We now see that our image is formed at 2F. It's inverted, it's a real image because I can project it on a screen, and it's the same size. So now if I move the object even closer between F and 2F, and I draw my parallel ray to the axis that is going to pass through F, and I draw my ray from the top of the object that passes through the center of the lens, we can see they're going to cross over here outside of 2F, and now I'm going to get a magnified image because it's got even bigger. It's still inverted, and it's a real image because I can project it onto a screen. If I move the object even closer now to one focal length from the lens, and I draw my rays, here's the parallel one, it changes direction at the center of the line, and then it's going to pass through F. And then we've got the ray that comes from the top of the object and through the center. You can see that these rays are running parallel and they're never going to meet. So in this case, we don't get an image formed, and that's if the object is at one focal length from your convex lens. If we move the object even closer to within one focal length, we draw in the parallel ray to the axis that passes through F. We draw in the ray that goes through the center of the lens and doesn't change direction. We can see that these two rays are diverging from each other. So we have to do what we started doing with the concave lens. We're going to backtrace the rays with these dashed lines, and we're going to see where they cross over. Now, because we've had to do this, this is a clue we're going to get a virtual image. So here I then would draw in my dashed image to show it's virtual. So I'm going to have a virtual image, it's upright and it's magnified. And that's for when the object is closer than one focal length to the lens. Let's have a go with some concave lenses now. So we're going to do the same thing, put the object in, draw one ray parallel to the axis. It's going to change direction at the center line, but we know it's not going to go towards this F, it's actually going to go towards this F. So what we do is we get our ruler, put it on the paper, and line it up from this point to this focal length. You draw the dashed line up to that point, and then your ray is carrying on beyond the other side. Now if we put the ray in that comes from the top and passes through the center, it doesn't change direction and goes off in over there. So what sort of image are we going to get in this case? We're going to get a virtual image. So we can see that this is the point where the two rays cross. So it's a virtual image, it can't be projected on a screen. We can see that the image is upright and diminished. So a virtual, upright, diminished. So what we'll do now is we'll have a little look at what we can use these different types of situations for with different lenses. So the first situation we saw, we had an object outside of 2f with a convex lens. We'd use this in cameras. This is what's going on in your eye. We use this every day. Every time you see something, you've got a real inverted, diminished object, diminished image, with a convex lens. And we know it's diminished because if you saw something as big as a camera and you think about how big your retina is in your eye, obviously the image has got to be smaller. We look at the second situation. This is a bit old school now, where we had the object at 2f and the image at 2f. This would be a copying camera. A little bit old school compared to Google Classroom, but hey. If we move it even closer, we've got a projector. These are pretty old school projectors, but this one's a bit newer here. So this is still applicable. So this is when we're going to get a real inverted and magnified image. And then we had the situation where we had the object at f and the rays didn't cross. They just went on forever. And this is what we use in searchlights, like if you're calling Batman. And then we moved the object even closer inside of f, and you get a virtual upright magnified images. This is what you've got with magnifying glasses. And we will stop